Okay, this is video number 2 on solving. So if you need to, then go back and watch video number 1, which reviews all of our solving things that we remember we need to do. So I'm just going to talk about them on this video, and you can go back and review them. So as soon as instructions say solve, we're going to look at our equation and see if we can do any of those things that we had for simplifying, which would be distributing, adding like terms, or clearing fractions. Well, in this case, we definitely have a fraction. So here we'll write down, what do we do to clear fractions? Okay, so let's kind of make our steps here for what we do to clear fractions. So first thing we would do is we would find the least common denominator of all denominators. Now, if you don't remember how to do the least common denominator, I have a review video on that. So please review that. We'll talk about it as we do it, but you still need to go through it and make sure you know how to do that. And then after you've found the least common denominator of all the denominators, then you're going to multiply every term, not just some terms, every term by the least common denominator. That's on both sides, okay? Every term. All right, so that's important, whether they had a denominator or not. You multiply every term by that, and then you're going to basically reduce all your fractions. So I'm just going to write reduce because you're going to have stuff that you can reduce on that. Okay, so let's start with this first example. So I see a fraction there. So I'm going to find the least common denominator of all the denominators. Well, that's pretty easy because there's only one denominator, and that's an 8. And so we're going to multiply every term by that least common denominator, which means we're going to multiply every term by 8. So there's only one term on the left, so we're going to multiply it by 8. And there's one term on the right, so we're going to multiply it by 8. Then we're going to reduce any fractions that can be reduced. Well, that's only this one because this is the only fraction that has a denominator and a numerator. And now you have 8 over 8, so you can reduce that. You cannot do any reducing over here. There was no denominator, so that just stays 6 times 8 for now. Now we'll write down what we end up with, what we have left. So we have a negative 3 times a 1 times an x. So the left is negative 3x. And then we simplify the right. 6 times 8 is 48. And now the problem is just like what we did on our other videos. So all we're going to do is the same process. So we're going to divide by negative 3 because both sides already are isolated correctly. And then we're going to write what we have left. So negative 3 divided by negative 3, of course, is 1. So we get 1x equals, and then 48 divided by negative 3 is negative 16. Remember, if you struggle with arithmetic, use your calculator. And so that's it. There's your answer. So the problem ended up being really easy once we got rid of the fraction. So we'll do the same thing here. So this time I have 3 denominators. So all 3 terms have denominators. So I need to find the least common denominator. So to find the least common denominator, you're supposed to factor all the denominators, but they already are factored. They can't get any smaller than that, any different than that. And so now I'm going to take the product of all the factors using repeated factors only once and just using their highest power. So I have a 3 that I need times, I take the product of these, I need a 5, and then I have another 3, but I don't need it again because I already used a 3. This is a repeated factor, so I don't need it twice. So the least common denominator is 15. So that means I'm going to multiply every term by 15. So I'm going to put times 15 times 15 times 15. Then I need to go through and reduce every fraction, which is the reason that we did this, is so that all of them now have something in the top in common with the bottom. And remember, we didn't change the problem because we did the same thing to the left and to the right. We just made it look different. So now we divide 3 by 3 and 15 by 3, because that's what they have in common. 5 and 15 have a 5 in common, so I divide 5 by 5 and divide 15 by 5. And then we have 3 and 15 again that have a 3 in common, so I divide 3 by 3 and 15 by 3. Then I need to write down what's left out of all of that after I've done all this reducing. And again, remember, this is a video. You can pause it at any time, rewind, anything you need to see again. So I'm going to put my equal sign here so I keep it lined up. And then I'm going to look over here on the left. All I have left is 5x. On the right, my first term is just got 3x left, and then I have the plus sign, and then I have 7 times 5, which is 35. And so again, now the problem is really easy. So now we can do the problem a little bit quicker because we've reviewed this. So we need to get variables on one side, constant on another. This already has a variable only. So I'm going to subtract 3x from both sides. And then I'm going to do this. So 5x minus 3x is 2x. 3x minus 3x is 0, which is why I did that. Then I have just 35. And then I divide both sides by 2. Oh, sorry, crossed through the 2, didn't mean to do that. And so I end up with 2 over 2, which is just x, 1x, and 35 over 2, which you can leave 35 over 2, or if you have a calculator, you can also write 17.5. It doesn't matter. 35 over 2 is perfectly fine, so I'd even prefer you just leave that. Okay, so let's go to number 7. So number 7, we have denominators. We have an 8 and we have a 6. This one doesn't have a denominator, but it's still one of the terms. So we need to find the least common denominator. I'm going to go way over here to find the least common denominator, so I'm way out of the way of my problems. This time I have a 6 and I have an 8. So I'm going to have to factor your 6, that's 2 times 3, and factor the 8. Well, the 8, if you need to, you can do a factor tree. It's going to be 2 times 4, and then 4 is 2 times 2. So you're going to have 2 cubed. And then to find the least common denominator, we take all of these denominators, and that's kind of hard to see that this is 2 cubed, but this is 2 to the third, and this is 2. So that's repeated factor. It's in both of the numbers. So I use this highest power, which is 2 cubed. And then I also have this 3. So I have 2 cubed times 3. 2 cubed is 8. So I have 8 times 3, which is 24. So I'm going to multiply every term here by 24. And I'm going to use a little thin line here. So I'm going to do times 24. Times 24, this is the one that gets missed the most. Just because it doesn't have a denominator doesn't mean you don't multiply it, because you completely change the problem if you don't multiply every term by 24. And now what I need to do is reduce all these fractions. So I have an 8 in the bottom and a 24 in the top. So they have an 8 in common. So divide by 8, you get 1. Divide by 8, you get 3. Here I don't have a denominator, so I just leave this. Here I have a denominator of a 6. So there's a 6 in the bottom and a 24 in the top. So I divide by 6 and I divide by 6. Then I'm going to write down what I ended up with. So I'm going to keep my equal sign here. On the left, this is a 1 in the bottom, so I don't need to do anything with that. And then I have a negative 3 times 3. So that's negative 9. this term is just 24x because I don't have any denominator to simplify. That's just 24x. And then here I just have a 5 times 4. Just make sure you keep that minus sign. So it's minus 5 times 4, or minus 20. Now the problem is so much easier. It looks just like a normal problem now. So now you just solve it like before. So I would suggest, especially if we're having trouble with signs, change this to add the opposite for your subtraction there, so that I can see what I need to add to both sides is actually 20, because the right side's the only one that was mixed with variables and constants both. So it's the one that needed to get fixed. And then on the left, I'll have positive 20 minus 9, which is going to be 11. And then on the right, I'll have 24x. And then I have negative 20 plus 20, which is 0. 24x plus 0, just 24x. Now I'm going to divide both sides by 24. So I can get a 1x. And then remember, I don't need my calculator. It's 11 over 24. Just leave it. And then 24 over 24 is 1, so I get 1x. Okay, last example for this video of solving is to do one with decimals again. So again, I don't care that it has decimals, just do your normal stuff. That's really all that's needed. Okay, so we look at the problem, and we definitely see that we could distribute on the left. The right-hand side, I really don't have anything I can do, but the left-hand side I can distribute. So you draw the arrows if you need to remind yourself that 4 gets multiplied by both of those things. So 4 times x is 4x plus 4 times 2.5, which luckily ends up being 10. So now we don't have a decimal there anymore. And then we have a minus x, and I'm going to go ahead and write it as a minus 1x plus 11.7. Remember that it's sometimes helpful to put that 1 there. Now I'm going to look at the problem again. Left-hand side, variable term and constant. Right-hand side, variable term and constant. So I want to get those together. So we're going to use the same idea where we always move the smallest x first. So the negative is certainly smaller than the positive. So I'm going to add 1x to both sides so that I'm adding the opposite, because negative 1x and 1x will give me my 0. Now we have 4x plus 1x, which is 3x, and then we have plus 10. Negative 1x plus 1x is 0. That's why we did that. And now we just have 11.7. So now we're going to fix this side is the only one mixed. This side only has a constant. So we need to subtract 10 from both sides. And then we'll write down what we have left. And so on the left, we'll have 3x only, because 10 plus negative 10 will go away and be a 0. 11.7 minus 10 is just going to be 1.7. And then the last thing we're going to do is we're going to divide by 3 so that we have just the x. And so we have x on the left, and on the right we need to do 1.7 divided by 3. So you can definitely, again, should have a calculator on the test so that you can get that without having to worry. Now, if we do that in the calculator, it ends up being not a very fun decimal. So I'm actually going to do, you can definitely do this in the calculator. Just write the decimal that you get. I hopefully there won't be one like this on the test, but I would actually multiply the top and bottom both by 10. In other words, move the decimal over. I'm going to leave the answer as 17 over 30. But it is a decimal 0.566 repeating, which is actually 0.567. So either way. All right, so that is our solving number 2 video.